Ladies and gentlemen, welcome again to PASCO Laboratories. I'm JP, and this week the P stands for, well, it doesn't stand for, but I put the P in computational thinking. It's a big topic nowadays because many of our states have computer science standards, and we know that computational thinking often translates into coding. Now, our kids love coding, and of course we love things that our kids love because it helps us teach and it helps them learn. And we know that coding is very popular because it makes your classrooms STEM. So coding and STEM have gone hand in hand, and whether you're STEM or maybe you're STEAM or maybe you're STREAM, or like if you're like you, me, and Heidi, it's SCREAM. Regardless of what you are, this is always translated as coding, and coding has always translated to how we apply it in the classroom as robotics. Now, ladies and gentlemen, I have absolutely nothing against robotics. In fact, some of my best friends are robots. But in the classroom, this is how robotics translates. And try sending this home with your students. Try doing this in your classroom and learning anything about science. I love robotics, but it doesn't fit well in the science classroom. Wouldn't it be great if we could take something like robotics and use coding and learn with science and learn with mathematics and even integrate in some art? Well, there are some little tools that help us do that are currently available on the market. And the one thing I will tell you about these things is they are not necessarily kid-friendly, but you can get them to do things. And the problem is that you need a tremendous number of parts to go with it. So try sending this home and getting it back. Again, it's difficult. Wouldn't it be nice? Couldn't we just wish for a very simple solution that can do all of this with coding and computational thinking and let our students learn? Well, we can. And we did. And we're going to show you today live right here on PASCO Live. Ladies and gentlemen, let me introduce myself. I'm Dr. JP Keener. I'm the former director of STEM for the State Department of Education. And we're here with our studio audience. A round of applause for our studio audience today. And we're going to be talking a tremendous amount about hybrid learning. And so whether we're in the classroom or we're at home, we're going to show you something that works very nice and very easily with teaching computational thinking and doing it with science. The other nice thing is, to show it, we brought in a family from home. And so what we'd like to do is pop into our little Zoom connection and give a nice wave and hello to our McGeorge family. Hello, McGeorges.
Hello.
Excellent. The McGeorges will be joining us again shortly as we take a look at the lessons that they've been learning, and we'll introduce you to Lucy and Jack in just a minute. But most exciting for me is that I'm able today to work with the leading expert in computational thinking, brought computer science standards to the state of Florida, and now working with PASCO Scientific to develop a computational thinking, computer science standards integration with science and math and bringing that to our kids, and that's Miss Hbrennan. So, ladies and gentlemen of our audience and those of you at home, a round of applause for Miss Hbrennan. Now, if you've got any questions for Heidi and I today, just write them in. I'm trying to watch you live on Facebook and saying hello to our friends that are writing in. Janet is with us, and if you just holler out a question, they will holler out to us the question, and Heidi and I will be able to answer them. So, Heidi, welcome.
Hey, how are you doing?
I'm doing pretty well,
Fantastic,
thank you. It's nice to have you here.
Good to be here. Guys, I'm really, really excited to share with you PASCO's latest innovation, the code.Node. And before we show you some lessons in action, how you could do them in class or at home, I want to talk to you a little bit about the features of this code.Node. So with it, you have 6 inputs. I have a light sensor, a magnetic field sensor, motion sensor. I also have sound, ambient temperature, and then there's 2 buttons or switches on the bottom that you can also manipulate. The exciting thing about code.Node is not only do I have inputs, I have outputs that I can control. You have an RGB LED light, red, green, blue. You also have the 5x5 LED array, and then you also have a speaker that you can utilize. So this is a pretty amazing device, all compact and in one piece. All right, so let's visit Lucy and Jack at home. And Lucy, she's a 5th grader, and in her science class she's been learning about light behavior, and she understands that light travels in a straight line until it interacts with another object. we've also done a little bit of basic coding introduction into our classroom. So after this, I sent her home with a code node and gave her a challenge. And that challenge is she's going to program her light sensor and also work with the RGB LED to see if she can mimic an automatic night light. So, hey Lucy, how are you?
I'm good.
Awesome. I just wanted to check in and see how you did with your coding challenge yesterday. When you built the program, did you have any challenges? And if so, how did you correct those?
So one challenge I had was how to add the else onto the bottom of here. And what I did was I clicked this gear right here. I dragged this else over under this if, clicked it back, went to hardware, got this, and dragged it over here. And so I could then change the color of it.
Excellent job, Lucy. I'm pretty impressed on how you took over that hurdle and completed that challenge. So, did your program work, and how do you know?
It did work. So how I found out was I put all of these on 5, these on 0. I clicked done, start, put my light over it, and the light turned on.
Oh, that's fantastic. I see it working. Well done. All right, well, I'm going to give you another challenge. You ready for it?
Yes.
Okay, so in art class, I know that you've covered primary colors and color mixing. So using the program you have, can you alter it? Because I noticed your RGB light was white when you covered the light sensor. Can you program it so the light will be purple when you cover your light sensor?
Yes, because I know the red and blue make purple, so I can just turn the green one off and then click done, click start, my light over it, and the light turns purple.
Ah, that is awesome. Very cool, Lucy. Well done. All right, so it's time for me to start my next class, and we're going to go to Jack. And Jack's in 7th grade. He's had a few classes with block coding already under his belt. In mathematics, we've been covering probability and likelihood of events. So with these pieces, I sent Jack home with a code node and a challenge, and I asked him to use the motion sensor and the 5x5 LED array to create a random number cube generator. All right, so let's visit Jack and let's see how he did. Hey Jack, how are you?
Good.
Excellent, excellent. All right, so I'm curious, you had a pretty extensive program. You had a lot going on there.
Yeah.
How were you able to decipher each block from the next when you were building your program?
Well, when I booted up the code.Node system, I saw that some of the different blocks that you can use have different shades of color, and so does the little toolbar on the left. And then I realized that for example, if I wanted to find a hardware block which is yellow on the sheet that I received, I could just go to the yellow hardware section to find one of those blocks.
Excellent. Very good. All right, so you were talking about math blocks. Can you explain to me what absolute value is?
So for absolute value is basically, to put it simply, let's say we have a helicopter that is 60 feet off the ground, and we have a submarine that is 60 feet below the sea. Did I say ground? I meant sea. And since both of those have the helicopter or the airplane, or I don't remember, has a value of positive 60 feet, and the submarine has a value of negative 60 feet, then that means that although they're on different ends of the number line, that they have the same absolute value, which is 60.
All right, excellent job. So we know absolute value is always a positive integer. Very good. All right, so my next question to you, I love how you paid attention in mathematics class. That's fantastic. As you were building your program, you had a lot of blocks that were repetitive. Did you find an efficient way to duplicate anything or pull blocks easier?
Actually, yes, I did. If you're a keyboard user, then all you have to do is hold down Alt and then click with the mouse pad, and you'll find a little toolbar that says duplicate, which makes another one of that block that you can drag around. Although, of course, you can always use the mouse, which you right-click, then press duplicate again to get the same block.
Excellent. Very impressed that you figured that piece out. All right, so we've talked about some of the programming here. Let's get to the 5x5 LED array. How did you feel when you were building this piece? Did you have any challenges? Anything you want to share there?
Well, when I first used the little code node right here, I was confused on how to define the values that are in this little 5x5 grid. I realized that in the right angle you can see that there are these tiny little inscriptions, which I don't think the camera will pick up, but it says 00 in the top left, 40 in the top right, 04 in the bottom left, and 44 in the bottom right. That technically means that by following those 4 values, you can map out a sense of or location on the grid. So, for example, 22 right here is actually 2, 2, which is the center. I also found out that if you want to find the numbers easier without using the grid, you can just go to the hardware section on the toolbar and find this, which you can then use little check marks to make a picture.
Fantastic. Again, I love how you connected your programming back into mathematics, kind of looking at it like a coordinate plane and ordered pairs, and you worked through that. So great job in tackling this. So did your program work, and what does it do?
Well, it's actually pretty simple, says he. All you have to do is you have to, I just click done, and then I click start, and what you do is when you shake it a certain amount, it'll show like a number on a dice, like this.
Are you getting the same number every single time?
No, since I changed the dice roll variable in my code to go to a random integer from 1 to 6, it'll choose one of these 6 numbers up here.
That is fantastic. So hence your random number generator. Excellent job, guys. Terrific work. I've got one more question for you. How did you enjoy working with a code node at home?
It was awesome. It was easy to learn, and it was pretty useful if you want to do some fun things.
Yeah, it's fun.
Excellent. Got some good news for you guys. You get to keep those code nodes. Those now belong to you. Thank you so, so much. All right.
Thank you.
Well, guys, I cannot tell you just how excited I am as an educator to be able to utilize a tool like this, because now I can integrate coding into my classroom, but I'm still reinforcing those content areas. I'm bringing in mathematics, I'm bringing in science, I'm bringing in art, and I'm keeping these at grade level appropriateness. So it's an amazing tool, all in one piece, very easy to send home, very easy to manage in the classroom.
So Heidi, I love watching these kids. They've been great on the Zoom session,
yeah.
and I think our kids absolutely love this. But I couldn't help but to notice that there's probably different levels of coding experience that might be required. So is coding required or even necessary to do this?
No. As them having full knowledge of coding is not required. As a matter of fact, it's kind of that fun learning process that we know the kids really enjoy. You're going to have some students that have never worked with this initially, like Lucy, but she troubleshot at home. She was able to work this lesson out utilizing her family, her brother, and just some basic information in the classroom. Now, of course, you notice that Jack, he's had some coding experience in classes, so he was able to work with more in-depth programs, things that brought in more blocks, started working with absolute values. So no, coding is not required knowledge. They have fun learning it as they go.
And I think that's important. And I kind of opened this up talking about, like, if you're going to send this stuff home, or if you're going to send this stuff home, but you're okay with sending that home.
I'm okay with that because I've actually been a co-coach on these Lego type programs, and it's very tough to keep track of all these pieces. A lot of us had to use actual tackle boxes with stickers in them so we knew how many of each piece we had. This I don't have to worry about. It's all in one easy spot. If it has a little drop, it's going to be fine. You just don't want to put it in water. That's the only thing I wouldn't do with a code node.
I did notice while watching the kids, though, that they were, one of them at least was using a Chromebook, and
Yes.
another one was using a computer,
Yes.
and I'm assuming that anybody can use it on anything.
Yes, anybody can use it on anything. And the exciting thing is that the SparkView software is free on Chromebooks. You can also pull it on your cell phone.
I was just about to give you that challenge. I can do that on my phone too?
You absolutely can do it on your phone.
okay.
Yes, absolutely. Just download the SparkView software and you're ready to go.
And I'm guessing that there's a whole line of computational like aspects that can be taught with
Yes.
this. And we saw Jack using like an array, but I guess there are other things we can teach too.
Oh, absolutely. It's an important thing to remember that when we're talking about the computer science standards, which the majority of our states have adopted and are utilizing kindergarten to 12.
39 of them, I think.
Oh, 39,
right?
you're
Yep.
correct. Absolutely. Coding is just one piece of the computer science standards. So they are having to get into computational thinking like a software engineer might. It doesn't mean that everyone's going to be a software engineer. It just means that they know how to problem solve. They know how to decompose a problem. They know and understand truly what an algorithm is, that step-by-step process, how to program machines. So it's really valuable. It's a great tool to bring computational thinking into the classroom. And again, what's really exciting about this product is you're supporting the computer science standards, but I know that I need my kids to revisit my science standards, my mathematics standards, so they have that opportunity.
Which is why we say learn to code.
Code to learn.
Exactly. We've got a question coming
We
in.
have a question. What block code is used?
It's Blockly coding, and the background language is Lua with the program. But the great thing is the kids can click on that Lua piece in SparkView and see the coding language. You can't manipulate it, but it's a great way to help you troubleshoot with bugs. But we are using the Blockly coding software.
Right, and Blockly is very common. If you go to code.Org, if you want some
Yep.
kind of background, parents, teachers, if you want a background in coding, we always recommend go to code.Org and program.
That's how I
think
learned.
there's a dancing party there, and you can learn how to dance. But if you know how to code and you've already got some of this stuff, you might want some of the activities that are available. And we've got a whole bunch ready for you. In fact, if you go to PASCO.com and you visit our experiment library, you're going to find a growing list of activities. Just type in Blockly in the little search box and you're going to start seeing a growing population of activities that are written around just this type of opportunity with both the code.Node or any of our sensors. And if you didn't get to see last week, if you're curious to know,
yes.
like, how can I do this with any sensor? Just take a look in our archive. You'll find that last week we looked at using this type of Blockly programming and computational thinking with any sensor. But no doubt about it, the code.Node brings it home, makes it possible to teach at home easily, makes it possible to do that in the classroom easily, and makes it possible without the nightmare of having this mess. So we're very excited about that. So excited, in fact, that we've got a special deal just for you. If you reach out now to our sales director, Mr. Isaac Martin, if you reach out to him and tell him that, Isaac, if somebody calls and says that JP and Heidi sent us, you've got a special deal for them. And he's waiting to give that deal to you. Just reach out to Isaac and remember, JP and Heidi sent us, and Isaac is ready to make a special deal for you. And don't feel bad if you're not in the United States and can't reach Isaac. We've got over 100 international partners that are waiting to hear just the same thing. The code.Node's available. You can order it today. We can get it in your hands almost tomorrow, in your classrooms very quickly, in your households very quickly. Parents, teachers, I think everybody wants this wonderful device for teaching computational thinking, for teaching science. Watch where that goes. Nobody leaves the building without being checked. And ladies and gentlemen, we really want to thank you for joining us today. So a very special thank you to the McGeorges family. Thank you, McGeorges, for joining us today on our Zoom conference call back in your kitchen. We'll let your kids get back to work and back to school and back to lunch. And thank you to our studio audience here. Ladies and gentlemen, thank you. And for all of us here at PASCO, we wish you the best of luck, great teaching, and good day.